All right, so in this video, I'm just going to kind of go through a few examples of how to integrate using u-substitution. So let's just kind of jump right into the examples. All right, so here's our first one. All right, if you remember what I was saying in class, okay, you're going to want to usually make the innermost function our u, okay? So in this case, it's definitely going to be this t to the fourth plus 2t. That's being raised to that third power. It's kind of our innermost function. So I'll make that my u. Okay. And then we just need to find a differential here, which is just du. And that's just taking the derivative of t to the fourth plus 2t, which will just be 4t cubed plus 2 dt. All right, so we notice that up top here in our integral, we have something very close. We have this 2t cubed plus 1, okay? And here we have 4t cubed plus 2, okay? So I realized that I can easily get 4t cubed plus 2 to look like 2t cubed plus 1 if I just divide it by 2. So I'm just going to divide both sides by 2 here. So I'll have 1/2 du equals 2t cubed plus 1 dt. All right, perfect. So once I have that all set up, I'm ready to get my integral strictly in terms of u. I'll have the 1/2. You can just leave that out front, just a coefficient. Okay, and then I'll just have 1 over u cubed du. Okay, the 2t cubed plus 1, that came out in the du step. I replaced that with 1/2 du. The t to the fourth plus 2t, that came out as u, and I still have that u cubed there. All right, great. So this is not that hard an integral. I'm just going to make it 1/2 u to the -3 power. And then I'm just going to use the reverse power rule here. So add 1 to the exponent. So I'll have u to the -2. And then divide by my new exponent. So dividing by 2. 1/2 divided by -2 will be -1/4 plus c. Beautiful. All right. And once we have that, all we do is we are just plugging back in for u. Okay. So we will have -1/4 t to the fourth plus 2t, all that to the -2nd power plus c. And there we go. If you wanted to put it back, I'm running out of space here on the slide, but if you wanted to put it back with a positive exponent there, I'll write it over here off to the side. It would be -1/4 t to the fourth plus 2t quantity squared plus c. And there we go. Our final answer right there. All right. Just moving right along, right into example 2 here. Once again, I have a very similar setup. Okay, I have this thing, that 1 minus 4x squared, underneath the radical. Okay, so I'm going to treat that as my inner function. So I'm going to set u equal to that 1 minus 4x squared. I'm going to calculate a differential. So du equals -8x dx. Once again, I'm trying to get rid of that x up top there in my numerator, my original integral. Okay, here I have negative 8x. So similar strategy to what I just did. I'm just going to divide. So I'll have negative 1/8 du equals x dx. Great. So now I'm all set to get to put my integral all in terms of u. So I'll have negative 1/8 the integral of 1 over the square root of u du. All right, very similar to that last problem. I just need to write this as a fraction exponent and get it out of the denominator. So it would be negative 1/8 times the integral of u to the negative 1/2 power. All right, and now I'm ready to just use reverse power rule. So add 1 to the exponent. We'll have u to the positive 1/2. And then divide my coefficient by the new exponent. So negative 1/8 divided by 1/2 is the same as negative 1/8 times 2, which will be negative 1/4. Beautiful. Sorry for that very ugly 4 there. I'll fix that. All right, and now I've got to this step. All I got to do is once again plug back in for u. I know the 1/2 exponent's the same as a square root, so I'll just do that right now. Negative 1/4 times the root of 1 minus 4x squared plus c. And there we go. That right there is our final answer. Okay, example 3 here. We got some e's going on here, okay, but remember, e's look a lot more complicated than they actually are. Okay, they are actually quite easy to work with. So thinking about what to make our u here, okay, I see I have e raised to that exponent. All right, so I'm thinking let's try making that exponent our u. So u equals 6t minus t cubed. And then once again, let's get the differential. So du equals 6 minus 3t squared dt. Once again, we're going to try to make this section here look like what we have here. Okay, a very easy just division again. All right, 2t minus t squared times 3 would get us what we have right here. So I'm just going to divide the whole thing by 3. So it'd be 1/3 du equals 2 minus t squared dt. And now I'm set. Now I just need to get my integral all in terms of u. So I'll have the 1/3 e to the u du. All right, we know that e to the u is the easiest integral in the history of the world. It's just going to be 1/3 e to the u plus c. And then we just got to substitute back in for u. So we'll have 1/3 e to the 6t minus t cubed plus c. All right. Last example here for these, at least this basic video. Okay. So once again, very similar setup. Okay, we want to figure out what to make our u. once again, I have this portion here inside a radical. This portion out here, that 1/2 x cubed minus 1. It's not being raised to any exponent or anything. So I'm kind of treating this as my inner function. So let's try and make that u. And then once again, I'll just get the differential. So du equals 8 minus 4x cubed dx. All right, so now we run into a bit of trouble here, okay? We have the wrong signs and everything here. So remember, we want to get this 8 minus 4x cubed to look like that, ideally. All right, so we got to do a little bit of manipulation here. So first I'm just going to kind of write it in a different order just so it's easier to see. So negative 4x cubed plus 8 dx. All right, and then we see that if I divide each of these terms by 8, I'll get this, but the wrong signs. So I'll need to divide the whole thing by negative 8. So I'll have negative 1/8 du equals 1/2 x cubed minus 1 dx. Beautiful. All right, so now let's get our integral all in terms of u. So I'll have negative 1/8. All right, I'm just left with that radical now. That's square root of u du. And I'll just need to convert that to a fraction exponent before using the reverse power rule. All right, then I just reverse power rule. I just need to add 1 to the exponent. So I'll have u to the 5/4. And then divide by the new exponent, which is the same as multiplying by the reciprocal. So I'll have negative 1/8 times 4/5 u to the 5/4 plus c. So just kind of dealing with that fraction out front. That'll be, where am I? Negative 1/10. And then plug back in for u. I'll have 8x minus x to the 4th. And all that's going to be raised to that 5/4 power plus c. All right, so there you have it. That's all the examples on this video. Hope this helps.